floats 1,000,000 miles from Earth, held steady by nothing but physics and the hopes of 1,000 engineers. The James Webb Space Telescope wasn't just built to see stars. It was built to see beginnings, galaxies from a time when Earth didn't even exist, light that started traveling toward us before there were eyes to see it. But to capture this view of the early universe, we had to build something humanity had never built before: a telescope the size of a tennis court, so precise it could spot a bumblebee from the moon. It took 20 years. It almost didn't launch, but when it finally opened its golden eye, it changed how we see everything. This is the story of the James Webb Space Telescope. How it was made, what it sees, and why it might just be the closest thing we have to a time machine. You don't just build a telescope like James Webb. You invent it from scratch. Every part, every mirror, hinge, sensor, bolt had to survive the vacuum of space, operate at temperatures colder than Pluto, and fold up like origami for launch. The entire mirror is made of beryllium, coated in gold, and segmented into 18 hexagons. It's more than 6 meters across, big enough to catch ancient starlight, delicate enough to adjust itself nanometers at a time. And it couldn't be launched fully assembled. So engineers had to design a telescope that assembles itself in orbit. No second chances, no on-site repairs. It took over 2 decades, $10 billion, and more than 300 potential failure points just to make it to the launch pad. And it nearly didn't happen at all. At one point, the project was so delayed and over budget, Congress almost pulled the plug. But they didn't, because we weren't just building a telescope. We were building humanity's best shot at seeing the beginning of everything. And for that, every risk was worth it. Before James Webb, there was Hubble, launched in 1990. Hubble gave us our first real glimpse into the deep universe, the pillars of creation, the Hubble Deep Field, supernovas caught mid-collapse. It wasn't just a telescope, it was a revolution. But Hubble sees invisible and ultraviolet light, the kind of light our eyes evolved to see. It's like looking through a window into a room filled with fog. James Webb sees differently. It sees in infrared, longer wavelengths of light, invisible to us, but powerful. Infrared doesn't bounce off the surface. It slips through things, through clouds of dust and gas, through the veils hiding newborn stars and ancient galaxies. And that makes all the difference. Imagine Hubble as a lighthouse, shining across space. Webb is a heat sensor, searching not for light, but for warmth, for the faintest signatures of energy in the dark. Let's talk numbers. Hubble's mirror is 2.4 meters across. Webb's is 6.5, 3 times wider, and over 6 times the collecting area. Hubble orbits just 550 kilometers above Earth, practically next door. Webb was sent to Lagrange Point 2, a gravitational pocket nearly 1,000,000 miles away, where it could stay cold, undisturbed, and always in Earth's shadow. And while Hubble had a few repairs done in orbit, Webb has no backup plan, no rescue missions. Every single component had to work first try, no second chances. When you place their images side by side, same galaxy, same stars, it's striking. What looked like a faint smudge in Hubble's eye becomes a living, chaotic dance in Webb's. The blurry becomes crisp, the hidden becomes revealed. But this isn't just about sharpness. It's about access. Webb doesn't just take prettier photos. It sees things Hubble physically couldn't. The light that stretched so far, redshifted by the expansion of the universe. Hubble gave us the universe we thought we understood. Webb is showing us the one that was hiding behind it all along. The old telescope changed our perspective. The new one might change the entire story. Every image from James Webb is a postcard from the past. Because in space, distance equals time. The farther away something is, the longer its light takes to reach us. Some of the light Webb is seeing today began its journey more than 13 billion years ago, long before our sun formed, before Earth existed, before atoms knew how to make stars. Webb doesn't capture the universe as it is. It captures what it was, a time when galaxies were just forming, stars were just igniting, and darkness was finally giving way to light. And now we're going to see it, not as a simulation, not as an artist's guess, but as it truly looked at the beginning. A speck of sky, the size of a grain of sand, held at arm's length, and in that one tiny sliver, thousands of galaxies, some of them more than 13 billion years old. The light had been traveling since the universe was only a few 100 million years old, and Webb captured it. That image, called the first deep field, was just the beginning. Since then, Webb has turned its mirror toward the Carina Nebula, revealing colossal clouds where stars are being born in more detail than ever before. The Cartwheel Galaxy, a chaotic ring of stellar collisions over 500 million light years away. It's captured the atmospheres of exoplanets, not just seeing them, but analyzing their chemical fingerprints: water vapor, carbon dioxide, even haze. And then there are the surprises. Webb has spotted galaxies that are too massive, too early, challenging our models of how galaxies formed after the Big Bang. It's giving us puzzles we didn't expect, clues hidden in ancient light, slowly rewriting what we thought we knew about the early universe. And it's only getting started. This isn't just data. These are moments from the dawn of time, finally visible. The James Webb Space Telescope has been watching the universe for nearly 3 years, and already it's changed everything. We've seen galaxies too old, too bright, too early. We've watched stars being born, and we've read the chemical fingerprints of planets that might not be empty. But this is just the beginning. Webb was built to last a decade, maybe two. And if the universe is already giving up its secrets, imagine what's still to come. This telescope isn't just looking outward, it's looking backward toward the very question of how all of this began. Thanks for watching. If you enjoyed this journey through space and time, consider liking and subscribing. There's so much more coming, and trust me, you won't want to miss what's next.